Start. Problem yesterday. The sixth one. One is x into dy by dx plus 2y is equal to square log x. Right. So dy by dx plus 2 by x into y is equal to x log x. So if I take p to be equal to 2 by x and q to be equal to x log x, right? So y into, so look, y group y into e power of integral of, correct, equal to integral of e power integral of 2 by x dx, and you have another dx plus, right? So y into e power 2x, sorry, 2 by x integral is e power 2 log x. What is that 2 by x? Because I divided with x on 1. So if you want to form a linear equation, the coefficient of dy by dx will be 1. So this should be equal to integral of x log x into e power 2 log x dx. So y into e power log x square is equal to integral of x log x into e power log x square dx. But I told you one thing yesterday. E power log of f of x is how much?
f of x.
Correct. So this would be y into e power x square is equal to integral of x log x into x square dx plus. Oh, I'm sorry.
Sir, y into x square, sir.
Yes. So y into x square is equal to integral of x log x into x square dx plus c. Okay. Now listen to this carefully. X square y is equal to integral of x square into x is leave some space. X square into x. So this will be equal to x cube log x dx plus. So x square y is equal to x cube log x plus. When you apply this highlight, algebraic and trigonometric. So this is algebraic. Oh, sorry, logarithmic and algebraic. So this is 1, this is 2. So first function into integral of second function minus integral of derivative of first function into integral of second function. Integral of derivative of first function into integral of second function plus c. So x square y is equal to x power log x by 4, and here it will get cancelled, minus x power 4 divided by 16 plus c. So x square will cancel on the other side. So y is equal to x square log x by 4 minus x square by 16 plus cx power minus 2. I'll do the 13th one. So dy by dx plus 2y tan x is equal to sin x. Y is equal to 0 and x is equal to pi by 3. So P is equal to 2 tan x, Q is equal to sin x. So y into e power integral of 2 tan x dx is equal to integral of q into e power of integral of 2 tan x dx into dx. So y into e power of 2 times log secant x is equal to integral of sin x into e power of 2 log secant x dx plus c. So y into e power of log of secant x the whole square is equal to integral of sin x into log of e power of log of secant x whole square dx plus c. So y into secant square x is equal to integral of sin x into secant square x dx. So what is sin x into secant square x? Listen. So sin x into secant square x, I can write it as secant x into secant x, or sin x into 1 by cos x into 1 by, okay, I'll leave 1 as secant x itself. So sin x by cos x is tan x. So sin x into secant square
Tan
x,
x secant x.
yes, it is actually secant x into tan x. So what will you get? Solution. Y into secant square x is equal to secant x plus c. So y will be equal to secant x by secant square x plus c by secant square x. So y will be equal to cos x plus c cos square x. Okay. Now they told y is equal to 0 when x is equal to pi by 3. So substituted 0 is equal to cos pi by 3 is half plus c into cos square pi by 3 is 1 by 4. So c will be equal to 2, minus 2, right? When it is minus 2 substituted here, then y will be equal to cos x minus 2 cos square x. Okay. 14th one. 1 plus x square into dy by dx plus 2xy is equal to 1 by 1 plus x square. So this will be the last problem. Then I'll go to vector algebra. So y is equal to 0 when x is equal to 1. dy by dx plus 2x divided by 1 plus x square into y is equal to 1 by 1 plus x square the whole square. So p will be equal to 2x by 1 plus x square. Q will be equal to 1 by 1 plus x square the whole square. So y into e power integral of 2x divided by 1 plus x square dx is equal to integral of q, that is 1 by 1 plus x square the whole square into e power integral of 2x divided by 1 plus x square dx. So y into e power, this is going to be log of 1 plus x square is equal to integral of 1 by 1 plus x square the whole square into e power log of 1 plus x square dx plus c. So this would be equal to y into 1 plus x square is equal to integral of 1 by 1 plus x square the whole square into 1 plus x square dx plus c. So 1 plus x square will cancel this once. So what is integral of dx by 1 plus x square? So y into 1 plus x square is equal to integral of 1 by 1 plus x square is tan inverse x plus c. Cancel it once. The final answer will be y into 1 plus x square is equal to tan inverse x plus c. But y is 0, x is equal to 1. So I'll put y is equal to 0 here. So 0 into 1 plus 1 square is equal to tan inverse of 1 plus c. So 0 is equal to tan inverse 1 is pi by 4 plus c, which implies c is equal to minus pi by 4. So y into 1 plus x square is equal to tan inverse of x minus pi by 4. So with this, we are done with differential equations also. Now it's your time to practice. So I'll move on to the next chapter, that is vector algebra. write down the heading as chapter 10 vector. So here we already know what are scalars and what are vectors. So scalars are basically quantities which have only magnitude but no direction. So quantities which have only magnitude but no direction are called as scalars. Similarly, when you talk about vectors, quantities which have both magnitude and direction, along with which they obey vector laws of addition. Quantities which have both magnitude and direction, along with which they obey the vector laws of addition, are called as vector quantities. So, examples of scalar quantities are length, mass, time, distance, speed, area, etc. All these quantities are scalar quantities. Similarly, when I talk about the vector quantities, the examples are displacement, velocity, acceleration, force, torque, momentum. All these quantities are vectors in nature. Okay. Now, if I have 2 points A and B, and I drew a line between them, then it's called as a line segment. And to this line segment, if I give a direction, then it can be called as a directed line segment. So basically, a directed line segment is what is called as a vector. This is how it is represented. And it is denoted like this. Denoted as AB with a bar on top of it, where A is called as the initial point and B is called as the final point. Or this can also be written as a variable on top of which you have an arrow marker. This is read as vector A, and this is read as vector AB, or you can say AB vector also. Right. So since we know that vector has direction and magnitude, so direction is represented with an arrow mark and magnitude is represented with a modulus. So how do I represent this? If I write AB vector and put a modulus around it. This is read as magnitude of vector. We read it up. It's read as magnitude of vector AB, right? And I can also write it like this. If I write something like this, it is read as magnitude of A vector. So, since magnitudes are modulus values, magnitude of A vector less than 0 has no meaning. You can never represent it like this. Are you able to understand this? Yes. Right. So, based on certain parameters, we are going to classify the vectors as different types. So, we'll see the types of vectors. First is zero vector. So, a vector whose initial and final points coincide are called a zero vector, or it can also be called as null vector. And how is it represented as 0 with an arrow mark on top of it? Right? So the other way of writing it is, the other way of writing a zero vector is A vector, B vector. If you write something like this, you're able to understand that the initial and the final points are the same. Hence, it is going to be a zero. Second is unit vector. A vector whose magnitude is unity.
Sir,
That is, one unit is called
sir,
ah,
zero vector can also be obtained by two vectors having equal magnitude in opposite direction.
no, they are not zero vectors, they are equal vectors.
Sir, I didn't get you.
Repeat your question. If two equal vectors, repeat your question again.
Sir, zero vector can also be obtained by two equal vectors in opposite direction, right?
Yeah, that you can do. They get subtracted. But that is a mathematical operation. I have not yet gone to that point. So, magnitude of a vector and the most important significance, a point to be noted is unit vectors are used to represent direction of a given vector. Right? And the symbol used is A with a cap on top of it. So this is the symbol used for a unit vector. So how do you read it? You either read it as A cap or A hat. Okay. So the third type of vector is initial vectors. So these are the vectors with same starting point. So it is something like this. This is one. Next is collinear vectors. So two or more vectors are said to be collinear. Are said to be collinear if they are parallel to the same line. So this is one vector, this is another vector. If these two vectors are parallel to a given line, then they both can be said as collinear vectors. Mostly collinear and parallel vectors are the same. Equal vectors. So two vectors are said to be equal if they have same magnitude and direction. Meaning this vector and this vector are said to be equal if their magnitudes are same and directions are same. Then you can write A vector is equal to B vector. Sixth one is negative of a vector. So a vector magnitude is same as the given vector, but opposite in direction is called negative of a given vector. Meaning, if this is a vector, then if I define a vector in the opposite direction, it is called negative of a vector. So based on this, we are ready to solve exercise 10.1. So look at the example problem number 1. Represent graphically a displacement of 40 kilometer 30 degrees west of south. So here we need to know a particular point. So there is something called as southwest and west of south. They both are different. So southwest means exactly 45 degrees. Southwest means exactly 45 degrees. But when they say west of south, no, listen to this carefully. This is north, south, east, west. So west is here, south is here. So from south, you are taking a turn towards west through an angle of 30 degrees. So this is a vector whose magnitude is 40 kilometer and it is west of south. Is it here? Example number 2. Classify the following measures as scalars and vectors. First one, 5 seconds is obviously scalar. Second, 1000 centimeter cube. Centimeter cube is a measure of volume. So volume is again scalar. Third, 10 Newton. Newton is a measure of force. It is vector. Fourth, 30 kilometer per hour. So since they gave only magnitude, kilometer per hour is a measure of speed, which is scalar. Fifth one, 10 gram per centimeter cube. So gram per centimeter cube is density, hence it is scalar. And the sixth one is 20 meter per second towards north. This meter per second is speed. Speed with direction gives you velocity. So velocity is a vector. So example 3. So they are given something like this. C. B vector. Now, which of the vectors are collinear? So which vectors are collinear? Collinear vectors are A vector, C vector, and D vector. Which vectors are equal vectors? So equal vectors are A vector and C vector, which are co-initial vectors. So co-initial means you are able to see a point here. So co-initial are
B vector, C vector, D vector.
so B, C. Okay. So if you look at the exercise problem, they're exactly similar, which I'm reading to you. The next one is the next concept is addition of vectors. So write down when I say addition of vectors, according to mathematics, we are talking about the triangle law. If two vectors are represented continuously along the two sides of a triangle, then the third side is given by the closing side of the triangle taken in reverse order. So, if I take one vector like this and another vector like this, that is the ending point of first is the starting point of second, right? So then these vectors are said to be continuous vectors. Reza. So read the statement. If two vectors are represented continuously along the two sides of a triangle.
From that side is there because
Closing side of the triangle taken in the reverse order அப்படின்னு பார்த்தோம்னா from the starting point of the first vector to the ending point of the second vector. So if I take this to be C vector, this is A vector, this is B vector, I'll write it like this, A, B, C. Then AB vector plus BC vector is equal to AC vector, where AB and AC are continuous. Sorry, AB and BC are continuous. AC is taken in reverse order. Okay. Next is the parallelogram. So when I talk about the parallelogram law of addition, if there are two vectors which are co-initial, so if I have two co-initial vectors, then I can draw two vectors parallel to the co-initial vectors, two equal vectors to the given co-initial vector such that this is also B vector, this is going to be A vector, so that I complete the parallelogram. Then the diagonal of this parallelogram is, if I call it as C vector, then I can write C vector is equal to A vector plus B vector. So logic is very simple because if I close the upper part of the triangle, sorry, if I close the upper part of the parallelogram, if you see the lower part, it is going to look like a triangle. So just now we saw what is triangle of addition of vectors. By taking that into consideration, we'll get the required answer. Okay. Now the next question is properties of vector addition. So property 1 is for any two vectors A and B will get A vector plus B vector is equal to B vector plus A vector, and they are said to follow the commutative property. Commutative. They are said to follow the commutative property. Okay. Next is property number 2. For any three vectors, A vector, B vector, and C vector, then we can have A vector plus B vector plus C vector is the same as A vector plus B vector plus C vector. And this is called as associative property. Next is additive identity. So additive identity is given like this. So to a given vector A, if I add another vector, it should give back A vector itself. So A vector plus 0 vector is the same as 0 vector plus A vector is the same as A vector. Then the 0 vector is what is called as the additive identity, or I will call it as additive identity of A vector. Clear to this stuff? Next is multiplication of a scalar, multiplication of a vector by scalar. Okay. So if I have a scalar lambda, then lambda times A vector is what is called as vector multiplied with a scalar. So the meaning is very simple. Okay, listen. If I have this as A vector, then I can take another vector which is parallel to A vector, which I call it as half of A vector. Then this half is what is called as the scalar part. Similarly, if I take another vector which is twice that of A vector, I'll write it as 2 times A vector, meaning the third vector that I've written is 2 times the vector A. Similarly, if I have the vector which is in the opposite direction, where I call it as minus half A vector, so all these things are possible with respect to a vector. So this is what is called as scalar multiplication, or sorry, scalar multiplied with a vector. Next is formula for finding unit vector from a given vector. If you observe, if I have any vector A, then I can write it as magnitude of this vector times direction. Right. So this is magnitude, and this is going to be the direction. That implies A cap is equal to A vector divided by magnitude of. This is the formula used to find the unit vector from a given vector. Next is components of a vector. Okay. Suppose I have a person walking from A to B to a distance of 2 kilometers and B to C to a distance of 3 kilometers. Then, if I join A to C, okay, if I join A to C, then I can write AC vector as, see, since you guys know what are orthogonal unit vectors, I'm not specifically mentioning it. So AC vector can be written as 2 times I cap plus 3 times j cap. You know what is this I and j? So where I cap and j cap are called orthogonal unit vectors, and this 2 and 3 are called as the components of the given vector, right? So if I write AC vector, it can be written as xi cap plus yj cap plus zk cap, where ijk are orthogonal unit vectors in the direction of x, y, z respectively, and x, y, and z are going to be the components of AC vector. See, AC can be anything. If I took an example, that's a different story, but AC can be anything. So, when a vector is given like this, A vector is given as xi cap plus yj cap plus zk cap, then magnitude of A vector will be given as root of x square plus y square plus z square. So, based on this, we will see some examples. So, example 4, if find the values of x, y, z so that A vector and B vector are equal. So if I take A vector, it is xi cap plus 2j cap plus zk cap, and B vector is equal to 2I cap plus yj cap plus k cap. If they both are equal, so xi cap plus 2j cap plus zk cap is equal to 2I cap plus yj cap plus k cap. It's not 3 with the z. So x will be equal to 2, y will be 2, and z will be 1. So if I take an example 5, A vector is equal to I cap plus 2j cap, and B vector is equal to 2I cap plus j cap. Are they both equal? Why?
Because I and j values are
I and j, we call them as components. Since components of A vector and B vector are not same, they are not equal vectors. Sixth one. One. A vector is given as 2I cap plus 3j cap plus k cap. So we need to find a unit vector in the direction of this. So a cap will be equal to a vector divided by magnitude of a vector. So this would be 2I cap plus 3j cap plus k cap, the whole divided by square root of 2 square plus 3 square plus 1 square. So 2I cap plus 3j cap plus k cap, the whole divided by 4 plus 9 is 13, 13 plus 1 is 14 is going to be the answer. So you can write it as a cap is equal to 2 by root 14 I cap plus 3 by root 14 j cap plus 1 by root 14 760. I'll do two more problems and we'll find. So seventh one. Find the vector in the direction of a vector. So a vector is equal to I cap minus 2j cap that has a magnitude of 7 units. First find a cap. A cap is I cap minus 2j cap divided by square root of 1 square plus 2 square. So what will it be? I cap minus 2j cap divided by root 5. So we need a 7 times a cap. The coefficient of I is 1. Coefficient of j is minus 2. Actually, it is minus 2 square. I directly wrote it as 2 square. So 7 times a cap is equal to 7I cap minus 14j cap divided by root 5. That is going to be the answer. Eighth one. So a vector is equal to 2I cap plus 2j cap minus 5k cap, and b vector is equal to 2I cap plus j cap plus 3k cap. Find the unit vector in the direction of sum of these two vectors. So a vector plus b vector is 4I cap plus 3j cap minus 2k cap. So if I call this as c vector, then c cap will be equal to c vector divided by magnitude of c vector, which will be 4I cap plus 3j cap minus 2k cap divided by square root of 4 square plus 3 square plus minus 2 square. So it will be 4I cap plus 3j cap minus 2k cap divided by square root of 25 plus 4, that is 29. So 4I cap plus 3j cap minus 2k cap divided by square root of 29. So that is all for the session. Remaining concepts will see the next class. Put it down. Monday. Guys, we'll wind up.